In this video, I will show you how to factor a variety of polynomials. We will be using the box method, the grouping method, GCF, and difference of squares to factor these. Both the box method and the grouping method rely on our ability to make a product and a sum using the same two numbers. So let's practice that skill in problem number 1. The product has to be 24 and the sum has to be negative 10. Well, take your product of 24 and make a little list of all of the things you can multiply that will give you 24. For example, 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. These are all the ways to get 24. Now ask yourself, which one of these pairs can I use to get a negative 10 if I choose the signs right? Okay, I see 2 of them. Alright, I could get a negative 10 out of this pair if I have a positive 2 and a negative 12. And I can get a negative 10 out of this pair if both of these were negative. So which one am I going to choose? Well, I'm noticing that my product is positive. So I need the one that involves two numbers that are the same sign. So if I choose the 4 and the 6, to get negative 10, I will have negative 4 and negative 6. That's what the signs have to be to make negative 10. And negative 4 times negative 6 is positive 24. So this is the pair that works. 2 and 12 would not work because I would have to have a positive 2 and a negative 12, and that would make a product of negative 24. Okay, well, I guess that helps me to do the next one. Because for the next one is the same thing, but this time I want a negative 24. So this works out great because, like I said, if I do positive 2 and negative 12, that will give me negative 10. But positive 2 times negative 12 is negative 24. So this is the pair that I would use for this situation. Okay, now let's use that skill to actually factor a trinomial. As soon as you see that it is a trinomial, meaning 3 terms, you know you're going to either use the box method or the grouping method, which are really actually the same thing. So the first thing you do is you look for the common factor. I'm noticing that all of these are divisible by 2. So that's going to be the GCF. So I'm going to pull out that 2, and then I'm going to have a trinomial inside. So if I divide everything by 2, that's going to give me 3x squared minus 10x plus 8. So for the next several steps, I'm going to focus on this red trinomial. So the next step of the box method is to come up with a product and a sum involving the same pair of numbers. The product has to be A times C, 3 times 8. So that's going to be 24. The sum has to be the B value, which is negative 10. All right, this is the exact situation that we just looked at up here. Coincidence? I think not. Anyways, got carried away there a little bit. So to form the product and the sum, as I showed you above, you start with the product of 24 and you make that little list. I'm just going to do it over again. So we have the list 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And then you look at the sum and ask yourself which pair will give me negative 10. And we already discussed this on the previous problem, but these two were the two possibilities. Since we already discussed it, I'm going to just skip to the fact that 4 and 6 is the one that actually works, because we will have -4 and -6. And then if we do -4 times -6, that is positive 24. Okay, the 2 and the 12 won't give you a positive 24. Okay, so these are the numbers that we're using. So for the box method, next thing you do is you draw yourself a box. So here's my box. In the first square, you put the first term, so that's going to be 3x squared. In the last square, you put the last term, so that's going to be 8. In the other two boxes, you use the two numbers that you just found in order to split apart the middle term. So instead of -10x, I will write it separately as -4x and -6x. Again, I'm using the two numbers that we just found. Next, we do the GCF of every row and every column. The GCF of the top row is 3x. The GCF of the bottom row is -4. You can see that these are both divisible by 4. It's -4 because the first term is negative. Now, the GCF of the first column is x. And the GCF of the second column is -2. Again, I'm going with -2 because the first term is negative. So this gives me a binomial times a binomial. So this is going to begin to form my answer. So from the left side over here, I have 3x minus 4. And from the top, I have x minus 2. Now this is almost the answer, but don't forget about the 2, the GCF that we pulled out in the beginning. That still remains. So our final answer is this. When we have a binomial, I'm not going to use the box method or grouping. That's for trinomials. For a binomial, from what we've learned so far, all we have is the GCF and difference of squares. And sometimes we end up using both. But we start with the GCF. I can tell that both of these are divisible by 5. Anything that ends in 0 is divisible by 5. So I'm going to start by writing down a 5. That will definitely be part of it. But I also see that both terms have x's. The smaller amount is just 1x, so I know that's going to be part of my GCF. So my GCF is 5x. Now, to figure out what goes inside the parentheses, I need to divide by 5x. Okay, so here that's going to give me x squared minus, now I'm not sure what 320 divided by 5 is, but I'm about to find out. 64. And the x's cancel out, so it's just going to be 64. Now, do not make the mistake of stopping here. Always look to see if you have the difference of squares. Let's see. Let's break that down. Difference means subtraction. We've got it. Now, squares. For a variable, you just need an even exponent. Got it. For the number, it has to be a number times itself. 64 is 8 times 8, so that's a square. So yes, we have the difference of squares. And when you have the difference of squares, you can factor using the difference of squares pattern, which just splits each of these right down the middle. So x squared will become x times x. 64 is 8 times 8. And 1 is plus, 1 is minus. That is the difference of squares pattern. And then bring down your GCF. So this is the answer to number 3. For number 4, there is no GCF to take out. So, and it's only 2 terms. So all we have is GCF and difference of squares. So since there's no GCF, hopefully this is difference of squares. Otherwise, it's prime, unfactorable. But yeah, this is the difference of squares. It's subtraction, v squared, that's even, and the 16 is a perfect square, 4 times 4. So we can just go straight to the difference of squares pattern, which goes v plus 4, whoops. I said it goes v plus 4 times v minus 4. And that's it. Okay, they're giving us a lot of good hints here. So they're reminding us that there is a GCF, okay, because both of these are divisible by 3. So let's go ahead and take out that GCF. So I'll have 3, and then I'll have some parentheses. To figure out what goes inside of the parentheses, of course, I'm dividing by 3. So that's going to leave n squared minus 75 divided by 3 is 25. Now in the hint, they said then it will fit the difference of squares pattern. And of course it does. This is the difference of squares. So we can go ahead and use the difference of squares pattern, which goes n plus 5 times n minus 5. So just make sure you don't stop at the first step. You're going to lose a lot of points. And then we will bring down the GCF. So this should be the answer to number 5. So on number 6, I see we have a trinomial, and this is where we either use the box method or grouping. So the GCF is 2. All of these are divisible by 2. So I'm going to go ahead and bring out the 2. Okay, and then I'm going to think about what's left inside the parentheses. So if I divide everything by 2, that's going to be x squared plus 2x minus 80. Okay, so for the next several steps, I'm going to focus on this red trinomial as I do the box method. Now, the box method relies on a product and a sum involving the same numbers. The product has to be A times C, 1 times negative 80. So that's going to be negative 80. The sum is simply the B value, so that's going to be 2. Okay, now start with the product, which is negative 80. Now I'm just going to write 80 as I make my list. I want everything that I can multiply that gives me 80. Now, I could probably muddle through this just in my head, but this number is big enough that it might be convenient. It might be a good time for me to show you the calculator trick. So go ahead and hit the table button on your calculator. And then just type in the number that you want to make a list for and put divided by x. I always like to start at 1 because the list always starts at 1. And just keep hitting enter. And now the calculator is basically giving you the list. So we have 1 times 80 and 2 times 40. And notice that 3 gives you a decimal, so that's not going to be useful. All right, then I have 4 times 20 and 5 times 16. All right, notice that 7 is a decimal. but then I have 8 times 10. Okay, so there's the list. That's how you can use your calculator if you ever need it to generate the list. So it's time to look at each of these pairs and decide which pair can give me a sum of 2 if I pick the signs right. And you can probably see that that's going to be the 8 and the 10. Let's see, I want a positive 2. So if I go negative 8 plus 10, that'll be positive 2. So then that means I'll need negative 8 times positive 10, and that does make negative 80. So, time to make the box. Okay, in the first square, you put the first term. So that's going to be x squared. In the last square, you put the last term. So that's going to be negative 80. In the other two squares, you use the two numbers that you found to replace the middle term. So instead of 2x, I'm going to write negative 8x and 10x. Again, using the two numbers I just found. Now, to get the answer, I need to take the GCF of each row and each column. The GCF of the top row is x. The GCF of the bottom row is negative 8. Both of these are clearly divisible by 8, but I'm calling it negative 8 because the first term is negative. The GCF of the first column is x, and the GCF of the second column is 10. Okay, so I'm going to turn this into a binomial times a binomial. So that's going to be x minus 8 times x plus 10. All right, I got that from here and here. Now, please do not forget the GCF that you pulled out in the very first step. That is still part of your answer, so this is the final answer. All right, on number 7, it's a trinomial, which means we will use the box method or grouping. And so I'm going to go ahead and do that. But first, we have to check and see if there's a common factor. There's a hint that says that there is one. So obviously that's going to be 3. So let's go ahead and take out that 3. And then we will divide everything by 3 to see what goes inside the parentheses. So that's going to be n squared plus n minus, and I'm not sure what 168 divided by 3 is, but I'm about to find out. 56. Okay, for the next several steps, I'm going to focus on this red trinomial. So I'm going to need a product and a sum for the box method. Okay, the product has to be a times c, so 1 times negative 56. The sum has to be the b value, which is 1. So let's make ourselves a list. Starting with the product, I see that negative 56, so I'm just going to write 56, and I'm going to make my list. Let's practice using that calculator trick I showed you on the previous problem. So let's go to the calculator, hit the table button, and let's just do 56 divided by x. So 56 divided by x. Start at 1. All right, and then the calculator gives you the list. So I've got 1 times 56, 2 times 28, 3 is a decimal. Okay, I've got 4 times 14. All right, 5 and 6 are both decimals. And then I've got 7 times 8. All right, so there's the complete list. Which one of these pairs will give me a sum of positive 1 if I pick the signs right? Clearly, that's going to be 7 and 8. Now, I need a positive 1. So let's see. That means I will need a negative 7 and a positive 8. That will add up to positive 1. So then I have to use negative 7 times positive 8 for the product. And that does give me negative 56. So we found the numbers that we needed. Okay, so it's time for the box method. All right, it's time for the box. So we will just go ahead and draw our box. All right, in the first square, we put the first term, which is n squared. In the last square, we put the last term, which is negative 56. In the other two boxes, we use the two numbers that we just found in order to split up the middle term. So instead of 1n, we will have negative 7n and 8n. Now we find the GCF of every row and every column. The GCF of the first row is n. The GCF of the second row is negative 7. Both of these are divisible by 7. The reason why I say negative 7 is because the first term is negative. The GCF of the first column is n, and the GCF of the second column is positive 8. So, using these purple numbers on the left and the top, I can begin to form my answer. I will write a binomial times a binomial. N minus 7 times n plus 8. However, do not forget the GCF that we pulled out on the first step. That is still going to be part of your answer. So this is the final answer for number 7. For number 8, as soon as I see that we have this trinomial, I know we're going to do the box method or grouping. And but first we have to do the GCF. So there is a common factor. Look at all these p's everywhere. So I'm going to pull out some p's. But how many? You always pull out the smallest amount that you see. So that's why I'm going to pull out p squared. So then I'm going to have some stuff inside the parentheses. And the way I know what goes inside the parentheses is I divide by the GCF. So I have to divide everything by p squared. So that's going to give me p squared plus 10p plus 25. For the next several steps, I am going to focus on this red trinomial. And it's time to do the box method. Well, to do the box method, you need a product and a sum that involve the same two numbers. The product has to be A times C, so that's 25. The sum has to be the B value, so that's 10. So first let's start with the product, 25. I'm going to make a little list of all of the things I can multiply together to make 25. Starting with 1 times 25, and then ending with 5 times 5. Those are the only ways to make 25. Which one of these pairs could give me a sum of 10? Well, obviously it's the 5 and the 5. So if I go 5 plus 5, that's 10. And then if I go 5 times 5, that's 25. So these are the numbers I'm going to use for the next step. Time for the box. All right, time to draw the box. Okay, in the first square, you put the first term. So the first square gets p squared. In the last square, you put the last term. So 25 goes here. And the other two squares, I'm going to use the two numbers I just found to rewrite the middle term as two separate terms. So I'm going to rewrite 10p as 5p and 5p. So that's what goes here and here, 5p and 5p. Next, it's time for the greatest common factor of every row and every column. The GCF of the first row is p. The GCF of the second row is 5. The GCF of the first column is p. The GCF of the second column is 5. So this gives me a binomial times a binomial, which is p plus 5 times p plus 5. But do not forget the GCF that we pulled out in the beginning. The p squared is still there. It is still part of the answer. So this would be the final answer for number 8. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.